And atmospheric pressure is about 100,000 pascals. And 100,000 pascals is actually a very large number. For example, it means that 1 square meter of any surface should experience a force which is equal to 100,000 newtons. And 100,000 newtons is actually a huge force. It's similar to the weight of 4 Ram trucks. So imagine this table and 4 tracks on the top of it. This is how strong the atmospheric pressure is. Of course, there are many demonstrations which show the strength of the atmospheric pressure. And I don't have ability to show all of them, but you could watch some on the video. And I'm going to show 1 or 2. But first, I want to ask you a question, at least start thinking about it. If the atmospheric pressure is so strong, and if it exerts so huge force, then why we don't feel it? Why it doesn't crumble us? So these are possible answers. You can start choosing yours. Okay? And well, first I want to say what's happening in the picture. So right here in this area, in this corner, you see experiments done again more than 100 years ago. They were possible because this scientist Otto von Guericke perfected the pump, and he could use his pump to make, well, pretty good vacuum inside, well, anything he wanted to. So he used 2 spheres put together, sucked the air out, and then, as you can see, even 8 horses, 4 and 4, couldn't pull them apart. Well, I don't have horses here. Instead, I have some simple devices, like this one, for example. I believe everybody has something like that at home. So what's going to happen if I just put it on this plate? Nothing. But if I just push it, why do I need to push it? To move some air outside. So now it has lower pressure inside. And now, why doesn't it fall, the plate? Because from below, atmospheric pressure exerts force stronger than the force from above, plus the gravity acting on this plate together. How do I take it off? Well, the easiest way is to let some air inside. Done. Now I have a smaller version of that. It's just a suction cup. Still strong enough. Even the area is much smaller, which means the force is weaker, but still sufficient. But if I have 2, that's going to be basically Magdeburg's hemispheres. Magdeburg is the city where Guericke used to live. So all I need to, well, first of all, nothing, right? Because first I need to move the air out. So press them together. See? And I'm not faking it. It's really, really difficult to take them apart. I can apply horse. Nothing. But what can I do now? I can just let the air in. Done. There's one more experiment I want to show. However, there's a chance it might not work. It worked once when I tried it. But if something works once, doesn't mean it's going to work always because, well, errors, things might happen. All right. Take this away. Have you seen this? Probably you've seen commercials because this is a standard 4-pack of vacuum stacks, nothing else. And what I want to do, I want to take this empty can, it's been used, put it inside. Now I need to seal it up. Well, it is a little bit noisy, so now I'm going to ask you that question. What is the reason that this huge pressure doesn't do anything to us? It worked. If you move away the pulling, you can see that it works. You can see what happened to the can. I didn't touch it. What did it? Atmospheric pressure. Because this electric pump, even this very weak electric pump, was enough to get the pressure inside so much lower than the outside, so the outside pressure was sufficient to create a force strong enough to break this can, crash it. This demonstration has a name, crash a can. So, I already have some distribution.